Hello. So today I want to do a short video on deriving the formula for the equation of a cycloid. Okay, we want to derive a parametric formula. Because first let's see through a problem. So the problem is the following. So let's just say through a diagram. We have this floor and initially we have a wheel. So we have this circular wheel. Okay, and this is the problem. The wheel is going to roll on the floor from left to right. So it's going to roll in this direction. Okay. And let's say initially, this is the point P where it touches the floor. So this is the floor. Okay. Now, as it is rolling to the right or just rolling on the ground in the clockwise direction, it traces out a path. It traces out some path. Yeah. One can obviously, now the path, this path that it traces out, it actually turns out that it's a graph of a function. Yeah, but it's much more convenient to use the parametric equation because that's much more simple to state. Okay, and then it can be used to integrate the region effectively and so on. So initially, this is the situation. So you can just say the point is P. Okay, let's just the center. So yeah, so we want a parametric equation. So let's call this the origin. Okay, because we need to place this on the frame, and also let's make another assumption that this R is 1 because that doesn't really change anything. Okay, so we want to understand how does a point P move. If a point P is here somewhere, then what are the coordinates of that point? Okay, so we will have to pick some parameter with respect to which we can say, right, that when this parameter is this much, when the angle or something is this much, then the point x coordinate of the point P is this and the y coordinate is that. Okay, so what should be the parameter? So, well, the very natural parameter is to spot here is the following. I mean, you can pause and try. Yeah, but you see, when the wheel moves, it's really the center is what really stays there, right? So, for example, this point right here is, we know that it is, let's do it with a lighter stroke, is 0, 1. So that 1 really remains the same. Yeah, it just moves. So let's say that you are at a moment of time when this is t comma 1 or theta comma 1, but right now we don't see the theta. Usually, this is set as theta and some other, the motion can be broken up into components and things like that. But we are going to take a very simple geometric approach. Okay, nothing wrong with other approaches, but just a simple geometric approach here. Okay, so if this point is t comma 1, okay, if this is where the center has moved, then we can try to we can try to imagine what will the point P be? Where will the point P be in that case? Okay, so let us see. So with roughly, if I have drawn the diagram like this, then we can. So just drawing the circles to be disjoint just for clarity, nothing else. So it's small, just same circle, right? Same wheel. It is moving. So something like this. Now here is the key thing. So we should take, so this is let's just take this point. Let's say this point is Q. Okay, then we know that's what we have assumed, that PQ is T. Okay, this PQ is T, and initially, yeah, we have this. Yeah. Now let's imagine that the point P has moved to, so where would it have moved? I mean, so let's say it's moved here. Okay. Let's say that it has moved to this point. Okay. And now the question is how we can figure out this point. Okay. Well, so we can try to compare it with the initial state. Okay. That is, the thought is. So how do we compare it? So let's say this point Q was initially somewhere here. Okay. Let's say some Q, and let's keep it Q naught. Okay, let's call it Q naught. Okay, then the key thing to notice, and this is what is really the key thing, is that this angle theta, yeah, this angle theta and this angle theta will obviously remain the same. Yeah, because it's a motion, and as the wheel is rotating, the point P goes to P prime and Q naught comes to Q. So they are the same points on the wheel, right? On the same wheel. So they are obviously at the same angle. Okay. So that angle theta is going to be our key. Well, so I mean, if this angle is angle theta, and remember the radius is r, then what is the arc length? So and this arc length PQ naught is the same as P prime Q, and both are again this is is equal to theta. Okay, both are equal to theta. Okay. But then you see, if this Q naught point has come to this point Q, it means that the wheel has rolled, right? The wheel, so the wheel is rolling, right? And this Q naught comes to this Q. So this point is now touching. So it means that at some point this was touching, then this was touching, this was touching, and then this, and then Q naught ends up touching, right? But that just means that we basically traverse this part of the arc, this arc. Yeah, and that is the length PQ. Okay, so in fact, this theta is equal to T, or T is equal to same thing. Okay, now we can try to use this. Now we know that this theta is T. Okay, and T was our parameter. So based on that, we can try to find the P prime. Yeah. So based on that, how do we find P prime? Okay. So now that is just we can do some calculations and we can find. So let's do that. Yeah. So I mean, how do we? So we can first try to find the height. So if this is theta, then this is pi minus theta. Or should I be? No, this is a geometric figure, so there shouldn't be any problem. It's pi minus theta, and now we can find the height. Well, it won't matter, but the height, we can just take pi minus theta and calculate. So we know the radius is 1, right? And so if this is pi minus theta, then what is the height? So the height you can see is 1. 1 is this portion. So that's 1 plus this other portion, right? And so what is that? That is cosine theta. Yeah, that is just cosine theta. Yeah, sorry, cosine pi minus theta. Cosine of pi minus theta. That is just, it comes out to be 1 minus cos theta. So you see that's 1 minus cos theta is this entire height. So that is the y coordinate of P prime. Similarly, the x coordinate of P prime, well, we can just find this length. So we can find this length. Yeah, and that length is just sine theta. Yeah, but obviously that's not what P prime is. Yeah, you have to compare it with the origin. So the whole thing is theta, and so you have to subtract sine theta, right? So the y coordinate of P prime, so this is the x coordinate of P prime. Yeah, and the y coordinate of P prime is, well, I think I mixed up the t and the theta, but it doesn't matter. Yeah, so the P prime y is equal to theta minus sine theta. Okay, so basically t, you can say t goes to 1 minus cos t, comma t minus sine t. This, with respect to the parameter t, this is what the equation is, right? And this is where it kind of goes. It goes like this, and at some point it actually goes to the top. And when that happens, when you move by pi distance half and then move full, it should come down symmetric. Yeah, and then one can use this parametric form to actually find the area under that curve, which we shall see next time. So yeah, so this is the thing. So parametric equation of this is what is called a cycloid. Similar method can be used to find parametric equation of other types of motions. So you could have, like a concentric circles where you have a wheel inside of like a maybe, yeah, and then some variations, when bearing and one of them kind of rotates and the other one moves, and so its position with respect to and so on. They all have this similar kind of thing. Okay, yeah, the theta actually comes features in as displacement also. Okay, yeah, so that's it. Thank you.